Welcome. Today, we are going to explore a fundamental concept in coordinate geometry and mechanics, position vectors. By the end of this lesson, you will be able to describe the position of any point using vectors and calculate the displacement between two locations. Position vectors are special because they always start from a fixed reference point, which we call the origin, O. Suppose we have a 2D coordinate plane with the origin O at 0, 0. Let's place a point A at 3, 2. If we want to describe the location of point A, we draw an arrow starting at the origin and ending at A. We denote this as the vector OA, or simply the underlined vector A. If point A has coordinates 3, 2, then its position vector is the column vector 3, 2. This tells us to move 3 units right and 2 units up from the origin. Now that we understand what a position vector is, let's look at how we can use them to find the movement between two different points. This is called a displacement vector. Our learning objective is to calculate the displacement vector AB using position vectors A and B. Imagine we have 2 points in space, A and B. Point A has position vector A and point B has position vector B. If we want to find the vector that takes us directly from A to B, we call this vector AB. To get from A to B, we can think of a path using the origin. We could go backwards along vector A to get to the origin, and then forwards along vector B to get to B. Since going from A to O is the opposite of vector A, we write it as negative A. Therefore, AB equals negative A plus B, or more commonly written as B minus A. This is a vital rule to remember for your exams. The vector from A to B is always the position vector of the destination, B minus the position vector of the start. A. Just think, end minus start. Let's apply this end minus start rule to a specific example to see how it works with numbers. Our learning objective is to use column vectors to calculate displacement. Suppose we have 2 points, P and Q. The position vector of P, which we will call small p, is 2, 5. The position vector of Q, which we will call small q, is 6, 1. If we want to find the displacement vector PQ, we take the destination position vector Q and subtract the starting position vector P. Let's plug in our column vectors. We have the vector 6, 1 minus the vector 2, 5. To subtract vectors, we simply subtract the corresponding components. For the top row, 6 minus 2 gives us 4. For the bottom row, 1 minus 5 gives us negative 4. This result tells us that to get from P to Q, we must move 4 units to the right and 4 units down. Take a moment to look at the graph. Does moving right 4 and down 4 from point P actually land you on point Q? Yes, it does! This confirms that our vector subtraction correctly identifies the path between any 2 points. Let's try one more example that involves negative coordinates, as these are common areas where mistakes happen in IGCSE exams. Consider point R at negative 3, 2, and point S at 1, negative 4. First, we write down their position vectors. We want to find the vector RS, which describes the journey from R to S. Remember our rule, end minus start. Substituting our values, we get the vector 1, negative 4, subtract the vector negative 3, 2. Be very careful with the signs here. For the top component, we have 1 minus negative is the same as adding, so 1 plus 3 equals 4. For the bottom component, we have negative 4 minus 2, which equals negative 6. So, the displacement vector RS is 4, negative 6. This means to get from R to S, we move 4 units in the positive x direction and 6 units in the negative y direction. Let's check our goals. We defined the position vector from the origin O and used addition and subtraction for displacement using the end minus start rule. You have now mastered the basics of position and displacement vectors in 2D. Practice a few more subtractions to ensure you are confident with those negative numbers.